Hi everybody and a very warm welcome. Let's begin our discussion over the questions on areas of parallelograms and triangles. Coming up is the first question. It says that in this figure ABCDE is a pentagon. So ABCDE, you can clearly see 5-sided figure, 5 vertices, it's a pentagon. A line through B parallel to AC is drawn and this meets DC produced at F. So clearly BF is parallel to AC. Show that area of ACB is same as area of ACF. Is there anything difficult in this? Well, if I talk about the first part, triangle ACB and triangle ACF, both these triangles ACB and ACF are lying on the same base AC, lie on same base AC, and also they are lying between the same parallels, isn't it? The two parallels between which triangle ABC and triangle AFC are lying is BF and AC. They are parallel to each other, it's given in the question. And therefore, two triangles lying on the same base between same parallels have equal areas. So area of triangle ACB is same as area of triangle ACF. Second part says that area of AEDF is same as area of ABCDE, this whole pentagon. So see, clearly area of triangle ACB is same as area of triangle ACF. This we know. If in the triangle ACB I add this quadrilateral AEDC, I will get ABCDE pentagon. So clearly area of ABC triangle plus area of AECD quadrilateral will give me area of this ABCDE pentagon. So what I will do is I will add this AECD quadrilateral's area on both sides of this equation. So I will get, this implies area of triangle ACB plus area of quadrilateral AEDC is equal to area of triangle ACF again plus area of quadrilateral AEDC. When in triangle ACB's area I add quadrilateral AEDC's area, I get the area of the pentagon ABCDE. ABCDE. And in ACF triangle, when I add AEDC quadrilateral's area, I get AEDCF or AEDCF, or what is this? AEDF. AEDF also you can say, or AEDCF also you can say. So I get the area of AEDF, and that's what I wanted to show. Moving to the next question we have, in this figure PQRS and ABRS are parallelograms and X is any point on the side BR, you can see from the figure. Show that area of PQRS and area of ABRS is the same. Now this is very simple. PQRS and ABRS both are parallelograms lying on the same base RS and between the same parallels PB and RS. So firstly, parallelogram PQRS and ABRS lie on same base RS and between same parallels PB and RS. And therefore, we know that parallelograms lying on the same base and between same parallels have equal areas. So I will have area of parallelogram PQRS is equal to area of parallelogram ABRS. First part done. Second says prove that area of triangle AXS is half of area of quadrilateral PQRS or parallelogram PQRS. Now if you clearly see, if I talk about the parallelogram ABRS, then ABR is parallelogram and the triangle AXS are lying on the same base AS and also between the same parallels AS and BR. A triangle and a parallelogram lying on the same base and between same parallels make sure that the area of triangle is half of the area of that parallelogram. So as triangle AXS and parallelogram ABRS lie on same base AS and between same parallels BR and AS, therefore area of the triangle is half of area of the parallelogram. But area of ABRS we have proved is same as area of PQRS. So I can write like this. And therefore area of triangle AXS is half of area of the parallelogram PQRS, which I wanted to show. Next question we have, diagonal AC and BD of a quadrilateral ABCD intersect at O. So let's try to draw this parallelogram in such a way that these two triangles have same areas. Prove that this quadrilateral is a trapezium. So let's first just draw a rough trapezium so that we can understand what all we need to prove in order to show this figure is a trapezium. So I have A, B, C, D. The diagonals are intersecting at O. It is given that area of AOD, this is AOD because this is O, and area of BOC. These two triangles have same area. So area of triangle BOC is same as area of triangle AOD. I have to show this figure is a trapezium. So I just need to show one pair of opposite sides is parallel. If these two triangles have same area, if I add this area, this triangle's area, if I add to them, what am I going to get? I will get area of triangle ADO plus area of triangle ODC will give me area of triangle ADC. And area of triangle BOC plus area of triangle ODC will give me area of triangle BDC. So I am adding the same triangle's area on both sides, so it will not disturb the equality. So I am saying this implies area of triangle BOC plus area of triangle ODC is equal to area of triangle AOD plus area of triangle ODC. This gives me what? BOC's area plus ODC's area gives me area of BDC. And AOD's area plus ODC's area give me area of triangle ADC. Now please try to observe these two triangles BDC and ADC. If you observe these two triangles BDC and ADC, both of them are lying on the same base DC and have their same areas. Therefore, they will have same heights, which means they will be lying between the same parallels. And that is going to mean what? If these two triangles are lying between two lines AB and CD, these two lines have to be parallel, because these two triangles will have to lie between the same parallels because they have the same base and the same areas. So, areas are same, and triangle BDC and triangle ADC lie on same base DC. Therefore, they lie between same parallels. The two lines between which these two triangles will be lying, provided one of them coincides with the base, will be parallel lines. Is it understood? Because the two triangles which are having a same base and equal areas are over here lying between AB and CD. Therefore, they have to be parallel because of the result that we have done in our theories lectures. Okay? Moving to the next question, we have, why am I stopping over here? Because the moment I have proved that one pair of opposite sides is parallel in this quadrilateral, the proof is done that the figure is a trapezium. Next question says that in a triangle ABC, E is the midpoint of the median AD. Okay, so first of all we have to consider the median AD. So general triangle ABC, consider the median AD. This is the median AD, and E is the midpoint of the median. Okay. Now, AD is median of triangle ABC. Fine. We all have done this result. The very last result in the theory lecture said that median divides a triangle into two triangles of equal areas, and therefore area of triangle ABC, first of all I can write it as area of triangle ABD plus area of triangle ADC. But area of triangle ABD is same as area of triangle ADC by the result, because the two triangles in which this median is dividing the bigger triangle are equal in areas. So I can write area of triangle ABD again plus area of triangle ABD, because ADC's area is same as ABD's area by the result that we've done. This is twice of area of triangle ABD, which means area of triangle ABD is half of area of triangle ABC. Now please see, if AD is the median, when do I say AD is the median? When D is the midpoint of BC. If I know E is the midpoint of AD, when I will be joining B with E, then BE will be the median of triangle ABD, because E is the midpoint of AD, which is the side opposite to the vertex B. Therefore, of triangle ABD, BE is the median. BE is the median of triangle ABD, and therefore the two triangles in which this median divides triangle ABD will be equal in areas. So first and foremost I can write area of triangle ABD as area of triangle ABE plus area of triangle EBD. Right? And over here, because I know these two triangles have same area, because the median divides a triangle into two triangles of equal areas, so I will write ABE also as its area also as area of triangle EBD. This is area of triangle EBD plus area of triangle EBD, which is twice of area of triangle EBD. So area of triangle EBD, what is area of triangle EBD therefore? Area of triangle EBD is half of area of triangle ABD. But area of triangle ABD is half of area of triangle ABC. So half is already there, this much area is half of area of triangle ABC, and from here you get 1/4 of area of triangle ABC. You have got area of triangle EBD or BED as 1/4 of area of triangle ABC. Next question says that in this figure ABCD is a parallelogram, AE is perpendicular to CD, CF is perpendicular to AD. Measurements are given of AB, AE and CF, find AD. If it is given to you that ABCD is a parallelogram, I know area of parallelogram ABCD is length of a base multiplied by the length of the altitude corresponding to that base. If I take CD as the base, then you can clearly see AE is the altitude corresponding to the base CD, right? AE is the altitude corresponding to the base CD. So AE's length will be the length of the altitude corresponding to the base CD. So this multiplied by AE will be the area of ABCD. CD's length is given to me or not? AB's length is given to me as 16, but I know if ABCD is a parallelogram, then opposite sides are of equal measure. So even CD's length is 16 centimeters. And AE's length is given as 8 centimeters. If I take CD as the base, then AE is the altitude. So with respect to CD, this is my area of the parallelogram. Also, if I change the base, altitude is also going to change. I can find out area corresponding to any base, right? First I took CD as the base and then I took corresponding AE as the altitude. Now if I take AD as the base, then I will have to measure its length and I will have to multiply it with the length of the altitude corresponding to the base AD. Corresponding to the base AD, CF is the altitude, you can see. CF is the altitude corresponding to the base AD, so its length will be the length of the altitude of this parallelogram corresponding to the base AD, so I will be multiplying it by that to get the area. Area of the parallelogram ABCD from here is 16 into 8. Area obviously is going to come out to be same whether you take any side as the base and multiply it with the corresponding altitude, area will be same. So area when CD was the base and area when AD is the base, it's going to be the same. So whatever is the area is also equal to AD into CF. So AD I don't know, CF is 10, so AD comes out to be 16 into 8 upon 10, which is 12.8 centimeters. That's how you compute the side length AD. Next I have XY is a line parallel to the side BC of a triangle. Let's try to draw. I have a triangle ABC. This is A, this is B, this is C. It's saying XY is a line, this is X, this is Y, parallel to BC side of triangle ABC. Now it says BE is parallel to AC. This is AC. BE is parallel to AC, so this is BE. BE is parallel to AC and CF is parallel to AB. They meet XY at E and F respectively. Okay. So I will have to produce XY. This is E, this is F. Show that area of triangle ABE. So I will be joining this. Area of triangle ABE means this triangle's area. This. Area of triangle ABE is equal to area of triangle ACF. So join this area. You have area of triangle ABE should come out to be same as area of triangle ACF. How do you plan to show this? So over here, let me rub this extra part. So this is E and this is F. I have to show what? I have to show this triangle's area is same as this triangle's area. Carefully observe, you have FB is parallel to AC and you have XB is parallel or AB is parallel to EC. This is the given in the question. If FB is parallel to AC, then FB is parallel to YC. If FB is parallel to complete AC, then it is parallel to any part of AC as well. So FB is parallel to YC. Already FY is parallel to BC. And therefore FYCB is a parallelogram. Right? Moreover, EC is parallel to AB, so EC will be parallel to XB. Then I have XE will be parallel to BC, that is given to me. XE is parallel to BC because this entire FE is parallel to BC, so one of its parts will also be parallel to BC, not a problem. And that gives me XBCE is a parallelogram. So you have this. First is this is a parallelogram. And then you have this is a parallelogram. Both these parallelograms are lying on the same base BC and between the same parallels FE and BC, so they will have their areas to be same. So area of parallelogram FYCB is equal to area of parallelogram XBCE. Right. Now you focus upon one thing. This is a triangle and you have this as your parallelogram. Then you have what? So over here, if you see, you take this parallelogram and you take this big triangle ABC. Triangle ABC and parallelogram FBYC have the same base BC, right? And moreover, this parallelogram and again this triangle have the same base BC. So what can you say from here? If I have this parallelogram and I have this parallelogram, I have to actually show that this triangle and this triangle have same area. How will I be proceeding ahead using all the results that I have already done? In here, carefully observe, I have this triangle is a part of what? What is this triangle ABF and ACE parts of? What is this triangle and this triangle which we have to prove equal in terms of areas part of? Try to think upon this and we'll be right back with the same question. So guys, over here we have to show that this triangle and this triangle have same area. Let's just take the markings according to the question. It says XY at E and F respectively. So let me take this as E actually and this as F. Why? Because I want triangle ABE and ACF. Eventually we are getting the same triangles, just the notation is according to the question. So my parallelograms will be EYCB. This is EYCB and this is also E and this is also E. Fine. And over here when I was talking about the other parallelogram, here it will be FC. FC is parallel to XB and XF. XF is parallel to BC. So XBCF is another parallelogram. Both of them are lying on the same base BC and between the same parallels BC and EF, and therefore they are having the same areas. This is E and this is F. That's fine. Now how to show that triangle ABE has same area as triangle ACF? Try to observe one thing. This triangle AEB and parallelogram EBCY are lying on the same base EB and between the same parallels EB and AC. So I am saying triangle AEB and parallelogram EYCB lie on same base EB and between same parallels EB and this AC. Therefore, area of triangle will be half of the area of this parallelogram. We know this result. This is equal to half of area of the parallelogram EYCB. But area of EYCB is same as area of XBCF. And now if you focus upon triangle AFC and parallelogram XFCB, again they are lying on the same base FC and between the same parallel FC and AB. You can write this on your own. And therefore triangle ACF will have area half of the area of the parallelogram XBCF. So half of area of parallelogram XBCF is what is area of ACF. Why? Because you can write triangle ACF and parallelogram XBCF lie on same base, lie on the same base CF and between same parallels CF and AB. and therefore area of triangle ACF will be half of area of the parallelogram XBCF, which is same as area of triangle EYCB. So you will have half of area of triangle EYCB coming up, which is equal to area of triangle AEB. So both these triangles actually have equal areas. Next question, let's see, says what? It says that a farmer was having a field in the form of a parallelogram. So let's just draw a parallelogram and consider it as the field of this farmer. The name is P, Q, R, S. She took any point A on RS, okay, any point A on RS, and joined it to P and Q. Okay. In how many parts the field is divided? It's very obvious. Field is divided into 3 parts, 1, 2 and 3. What are the shapes of these parts? Triangular regions. Each part is a triangular region. One is triangle PSA, other is triangle PAQ, and third is the triangular region QAR. It says that the farmer wants to sow wheat and pulses in equal portions of the field separately. How should she do it? Equally she wishes to sow wheat and pulses. Try to see triangle PAQ and the parallelogram PQRS. Both are lying on the same base and between the same parallels. So I am saying triangle PAQ and the parallelogram PQRS lie on the same base PQ and between same parallels SR and PQ. Therefore, area of triangle PAQ will be what? Half of area of parallelogram PQRS. If this triangular region PAQ is half of this complete one, that means this and this is the other half. This is one half of this complete parallelogram. That means what you're left with is another half. So if you want to sow wheat and pulses equally in separate regions of this parallelogram, you can sow wheat over here, you can sow wheat over here in this triangular region PAQ, and you can sow pulses here as well as here in the rest of the 2 triangular regions. So it will be like from the entire parallelogram shaped field, half is consumed in the sowing of wheat and exact half other is consumed in the sowing of pulses. Or what you can do, if over here you are interested in sowing pulses in this half, then in these 2 pieces which constitute another half of the field, you can sow wheat. So if here you are sowing pulses, exact half of the field is now consumed with pulses. So the next half you can consume with wheat. These 2 are constituting the next half because this alone is one half. So these are the 2 options with the farmer so that he can sow or she can sow wheat and pulses in equal portions of the field separately. Next question says that the side AB of a parallelogram ABCD is produced to any point P, okay. So this side AB is produced to P and this ABCD is a parallelogram. A line through A and parallel to CP produced meets CB produced at Q, and then parallelogram PBQR is completed. Show that area of ABCD is same as area of PBQR. What you do is, this is a parallelogram. Consider the diagonal AC of the parallelogram ABCD, consider the diagonal QP of the parallelogram BPRQ. And now focus on the triangle ACQ and the triangle APQ. Triangle ACQ and triangle APQ. See, triangle ACQ and triangle APQ lie, you can see, on the same base, lie on the same base AQ and also lie between the same parallels AQ and CP, and therefore they are going to have the same areas. This implies area of triangle ACQ is same as area of triangle APQ. From the area of these two triangles, I remove the area of this common region in both the triangles. When I do that, I get area of triangle ACQ minus area of triangle ABQ will also be equal to area of triangle APQ minus area of triangle ABQ. So here you will be left with what? ACQ minus ABQ gives you area of triangle ABC, and APQ minus ABQ gives you area of triangle BPQ. If you carefully observe, ABC triangle and parallelogram ABCD are lying on the same base AB and between the same parallels AB and CD. So clearly area of triangle ABC is half of area of the parallelogram ABCD. Another way of understanding this is what, if you remember, a diagonal of a parallelogram divides it into two triangles which are congruent to each other, and congruent triangles have equal areas. So I can say diagonal of a parallelogram divides it into two triangles of equal areas. So this triangle will have area equal to this triangle, right? And therefore I can say area of this complete parallelogram is twice the area of the triangle ABC, or area of triangle ABC is half of the area of this parallelogram. So area of triangle ABC is half of area of the parallelogram ABCD. Exactly in a similar sense, this QP is the diagonal of the parallelogram PBQR. So it will be dividing it into two triangles of equal areas. Fine. So definitely the triangle PBQ will have area half of the area of the parallelogram PBQR. So this triangle also has area half of area of parallelogram PBQR. Half cancels out, you have got what you wanted to show. Clear? Next question says what? Let's see. In this figure, diagonal AC and BD of a quadrilateral intersect at O such that OB is same as OD if AB is same as CD. So AB is given same as CD. Show that DOC triangle has area equal to AOB. DOC has same as AOB area. What you do, you drop perpendicular from here to here. Let this point be S, and again drop a perpendicular from here to here. Let this point be T. If here it is 90 degrees, even this is 90 degrees and this is also 90 degrees. Focus upon the triangle DOS and BOT. Clearly you can see one angle is 90 degree each. These two are equal because they are vertically opposite angles, and you have DO same as BO because it is given to you. So by AAS congruence condition, these two triangles come out to be congruent. So I say that angle DSO is equal to angle BTO 90 degrees by our construction. Angle DOS is equal to angle TOB, vertically opposite angles, and OD is same as OB, that is given to you. So therefore by angle side congruence rule, I get triangle DOS is congruent to triangle BOT. Fine. The moment two triangles are congruent, their corresponding paths are equal. So I will be having DO is same as BO, which is given to me. OS is same as OT, which is okay. DS is same as BT is what I actually am interested in. So this implies DS is same as BT. So you have got DS is same as BT. Fine. Now that you have got this, now focus upon the triangle DSC and ATB. You can see that one angle is 90 degrees here, one angle is 90 degrees here. DS is same as TB, we have proved this, and CD is given to be same as AD. This is AB, yeah. CD is given to be same as AB, and therefore by RHS congruence condition, both these triangles are also congruent. So if they are congruent, what do you mean? That area of triangle DOS is same as area of triangle BOT. Fine. As I was saying, you have angle DSC same as angle BTA 90 degrees by construction. Then hypotenuse is same, DC is same as AB. This is already given to you. And I have just proved from here DS is same as BT by CPCT. Therefore, right angle hypotenuse side by RHS congruence condition, you have which triangle congruent to which triangle? Triangle SDC is congruent to triangle DBA. No, DBT. This is what? ABT. Yeah, so it is ABT. I have triangle SDC congruent to triangle TBA or ABT, you can say, yeah. So from here I have SD is same as BT. So let me write this over here and this over here. So I have SD is same as BT, DC is same as BA, and SC is same as TA, because corresponding paths are equal. If these two triangles are congruent, this implies area of triangle SDC is same as area of triangle TBA. Add 1 and 2, what do you get? Add 1 and 2. Here you have area of triangle DOS is same as area of triangle BOT, and here you have area of triangle SDC same as area of triangle TBA. If you do 1 plus 2, LHS gets added and is equated to the sum of the right hand side. So area of DOS and area of SDC. Area of DOS and area of SDC gives you area of the triangle ODC. Area of triangle ODC. This is equal to area of triangle BOT plus area of triangle TBA. Area of triangle BOT plus area of triangle TBA gives you area of triangle OAB. And that is what you wanted to show. So we've shown the first part. Now see, let me rub this. If these two triangles ODC and AOB have equal areas, if I add this triangle's area to both the triangles, what will I get? Area of triangle ODC plus area of triangle OCB will also be same as area of triangle OAB plus area of triangle OBC. So if these two are same, that means area of triangle ODC plus area of triangle OCB. I am adding the same quantity on both sides, so my equation will not get disturbed. This is equal to area of triangle OAB plus area of triangle OCB. That is going to give me area of triangle ODC plus area of triangle OCB will give me area of triangle DBC or DCB, you can write, and I will have it equal to area of triangle OAB plus area of triangle OCB. OAB plus OCB give me the triangle ACB. This is equal to area of triangle ACB. And that is what I want to show as the second part. Then I want to show that DA is parallel to CB. Clearly see, if you can recall the result, very, very important result, you are having triangle CDB and triangle CAB, both triangles lying on the same base BC and having equal areas. So definitely the two lines between which they will be lying have to be parallel so that they can have same heights, right? So these two triangles have same areas and triangle DCB and triangle ACB lie on same base BC, and therefore they have same heights. That means they are lying between the same parallels. Right now the two lines between which they are lying is AD and BC, so AD will have to be parallel to BC. Therefore AD is parallel to BC. So many results used in one question, right? Next we have, in this figure, P is a point in the interior of the parallelogram. Show that area of triangle APB plus area of triangle PCD is half of area of the complete parallelogram ABCD. To show this, what I do is, I actually take a construction. I draw a line passing through P parallel to the side CD. So I name this line as, say, EF. So I say draw EF parallel to CD. Now can you see that triangle DPC and parallelogram EDCF? Why parallelogram? Because EF is drawn parallel to CD. Already AD is parallel to BC because it's given. This is a parallelogram. So part of AD will also be parallel to part of BC. So ED will be parallel to FC. So I have EFCD is a parallelogram. Both the triangle PDC and parallelogram EDCF are lying on the same base CD and between the same parallels EF and CD. So area of triangle PDC is half of area of parallelogram EFCD. Fine. Next, if I talk about this over here, if EF is parallel to CD but AB is already parallel to CD, that means AB is parallel to EF. So I have EF is parallel to AB, already AD is parallel to BC because ABCD is a parallelogram, so opposite sides are parallel, and therefore any part of it is also parallel to a part of it. So I have AE also parallel to BF. That gives me ABFE is again a parallelogram, and triangle APB and parallelogram ABFE both lie on the same base AB and between the same parallels AB and EF. So even area of the triangle APB is half of area of parallelogram ABFE. You can clearly write why, the reasons over here. I leave it to you. You can write the reasons very nicely, because the triangle and the parallelogram have the same base and lie between the same parallels in both the cases. So by using that result, that when a triangle and parallelogram lie on the same base and between same parallels, the area of triangle is half of the area of the parallelogram. When I add these two, what do I get? I get area of triangle PDC plus area of triangle APB is half of this plus half of this, half common, area of parallelogram EFCD plus area of ABFE, this parallelogram. What is EFCD plus ABFE? EFCD's area plus ABFE's area is the complete ABCD's area. So this is area of ABCD parallelogram, and you have shown your very first part. Clear? In order to prove the next part, what we do is, we draw a line, this time parallel to AD. Say this is E and say this is F. So I am saying draw EF parallel to AD. Okay? If EF is drawn parallel to AD, you can clearly see EF is parallel to AD, already AB is parallel to CD, so a part of AB is parallel to part of CD, so AF is parallel to DE, therefore AFED is a parallelogram. Both the parallelogram AFED and triangle DPA are lying on the same base AD and between the same parallels AD and FE. So area of triangle APD is half of area of parallelogram AFED. Similarly, if EF is drawn parallel to AD, AD is already parallel to BC because ABCD is a parallelogram, so opposite sides are parallel. Two lines parallel to the same line are parallel to each other, so EF will be parallel to BC. Already complete AB is parallel to CD, so any part of AB will also be parallel to any part of CD. So FB will be parallel to EC. I have FBCE is again a parallelogram. And triangle BPC and parallelogram BFEC are lying on the same base BC and between the same parallels BC and EF. Therefore, area of triangle BPC is half of area of the parallelogram BFEC. When you add these two, just like you did for the first case, you get area of triangle APD plus area of triangle BPC is half common area of parallelogram AFED plus area of parallelogram BFEC. Area of parallelogram BFEC plus area of parallelogram AFED gives you the complete area of the parallelogram ABCD. But by the first case, area of parallelogram ABCD is same as what? Half of area of parallelogram ABCD is area of APB plus area of PCD. And that is what you want to show as a consequence of the next part. So you have shown that the sum of areas of these two triangles is same as sum of areas of these two triangles. And that completes our discussion over all the questions. Please revise them very nicely. That's it from my side. Thank you.